right, so today's lesson is going to be on isotopes. What is an isotope? An isotope is an atom that has the same number of protons and electrons, but a different number of neutrons. And isotopes ultimately are what allow our periodic tables masses down here to be in decimal form. And we're going to learn why that is and how that gets calculated here in a few minutes. If we change the number of neutrons, we know that neutrons are found in the nucleus of the atom. So if we change the number of neutrons, we also change the mass. So let's look at chlorine. Chlorine has two isotopes, chlorine 35 and chlorine 37. So these are the mass numbers, 35 and 37. So let's take chlorine 35 and let's find the protons, electrons, and neutrons. Now chlorine is number 17 on the periodic table. So it has an atomic number of 17 protons. This is neutral. We know that because there's no oxidation number, no charges or anything there. So we know it's neutral, so protons equal electrons. And our neutrons are going to be found taking the mass of 35 and subtracting out the protons, which is going to ultimately give us a number of 18. What about chlorine 37? When we look here, the proton number doesn't change, because if I change the proton number from 17 to 18, I no longer have chlorine. So the proton number has to be 17 always. Again, this is neutral. We know that because there's no plus or minus with the value beside it. So that means protons and electrons are equal. And in order to find our neutrons, again, we take the mass number and we subtract out the proton number. So in this case, chlorine 37 has 20 neutrons. So what is the difference between these two isotopes of chlorine? Simply the number of neutrons. Now there's two ways to write an isotope. All right, we can write chlorine 35 like we have above, where we write out the element name with a dash and then the mass number. The other way we can write it is with the symbol, the mass number on top, and the atomic number on bottom. Now, we know the mass number is larger than the atomic number because mass contains two pieces, the neutrons and the protons, whereas the atomic number only contains the protons. So the mass has two things. The atomic number has one thing, so the mass is larger than the atomic number with the exception of hydrogen. What I'd like for you to do, I'd like for you to pause this video and I'd like for you to attempt to write chlorine 37 out in its two ways, then unpause and check your work. All right, so let's check our work. We could have written chlorine 37 out with the name of the element -37. The other way would simply be to write the symbol, the mass number of 37 on top, and the atomic number of 17 on the bottom. Now, let's investigate where the decimal places in the atomic mass on the periodic table come from. And so we're going to move into our worksheet, the average atomic mass. All right. We are going to do the first practice problem. All right, here. Find chlorine's average atomic mass if approximately 80% is chlorine and 20 chlorine 35 and 20% is chlorine 37. Now, to find the mass, this is a weighted average, the same way as I would do and calculate your grade at the end of the year. I take your assessments that you do and I multiply them by the correct percentage. We look at your labs, multiply them by the correct percentage, add it all together. So we're going to do the same thing. Chlorine has two masses, mass number 35, and my problem told me that approximately 80% of the chlorine on planet Earth is a mass of 35. So when I multiply by a percentage, 80%, I move my decimal place left 2 times. And then I'm going to add chlorine 37. And my problem tells me that approximately 20% of the chlorine on planet Earth is a mass of 37. And again, 20% would be 0.2 because I moved my decimal place left 2 times. And when we solve for this and you plug this into your calculator, you get a value of 35.40 AMU. Now we do want to make sure when we're doing a mass here, our average atomic mass, we want to go ahead and put 2 decimal places. All right, and this is an atomic mass unit. So what does this mean? Let's look at the atomic mass according to the periodic table, and that is 35.45. So this value we used a little bit more precise percentages, which is why it's slightly different, but that's okay because 35.45 is very close to 35.40. All right, so what does this tell us? So when we've been using the periodic table up to this point, we've been rounding to the nearest whole number. So these round to 35. So overall, which mass is the most abundant on planet Earth, meaning it appears most often? And that would be chlorine 35. So chlorine 35 is the most abundant, sometimes called the most common isotope. And when we rounded from the periodic table to the nearest whole number, that also gave us 35. So let's do one more practice problem, and we're going to look at number 2 here. All right, and we're going to look at oxygen. Now in this problem, and you may want to pull it up on your paper or the website because it is a little bit hard to see. I can zoom in slightly here for us so we can see. In this case, I've written our isotope with the other way to write the symbol. All right, where I wrote the O with the 16, that's the mass number on top. Okay, so each one of these problems has our isotope appearing in one of the 2 appropriate ways to write it. All right, so we're going to now calculate oxygen. And let me zoom back out a little bit here so that we can see all of the work. Okay. So oxygen, 99.76% has a mass of 16. So I'm going to do 16 times 0.9976 plus 0.04% has a mass of 17. So that's 0.004 times a mass of 17 plus 0.2% has a mass of 18. So my mass of 18 times 0.002 all right, 002. And when we plug this into our calculator, we get 16.00. So what does that tell us? When we look at our periodic table, what do we notice? The mass of oxygen is 16. So then when we round here, we would round to 16 because 16.0 rounds to 16. And what was the most common isotope of oxygen? and that was oxygen 16. 99.7% has a mass of 16. So what does this tell us? When we round our periodic table to the nearest whole number, we are actually rounding to the nearest or the most common isotope. So look at your periodic table. What is the most common isotope of lithium? All right, if you said lithium 7, you are correct. 6.9 rounds to 7. What is the most common isotope of copper? If you said copper 64, you are correct because 63.55 rounds to 64.